Hi, we are going to learn about definition of limits. So, for the limit of a rational function, normally it can be found by direct substitutions. So, the function will be in terms of fx over gx. After the direct substitution, we will have 4 possible cases. So, firstly, you will get a constant number, or maybe we will get a 0 at the numerator, or the 0 at the denominator, and the last one is both with 0. So let us look at 4 examples. For the example A, after the direct substitution, okay, we get that numerator denominator is a ratio of 3. So that will be the constant number. B, after the direct substitution, numerator with the 0 but the denominator with a 4. So logically 0 over 4 or 0 over any constant number, the answer it must be always 0. So how about the other 2 cases? So the example C and D will show you the example when the 0 over 0. So denominator is 0, there's a 0 of factor. And the example D is also denominator with 0. The only different part is the numerator is a constant number. So these two we cannot say that with the direct answer, but we call it indeterminate form for the example C, and the example D we will call it infinite limit. Okay, what is called infinite limit? Infinite limit, it can be denoted as positive infinity or negative infinity. So how we make a differences between it? So when the function increase without bound or decrease without bound when the x approaches a from the left and right. So when it's decreased, we will call it negative infinity. When it is increased without bound, it will be denoted as a positive infinity. So this is an example, left side limit and right side limit with the opposite direction. So this is what we call it, limit does not exist. If the limit exists, it must be both increasing or both decreasing. So let us look at the other example. From the calculator, when we key in the value approaches 1 from left or right, we found that the value is increased without bound. So we can conclude that the limit for this function when x approaches 1, it can be positive infinity. Let's get some example in finding infinite limit. So these are 2 different examples with the different denominator. We need to find the left and right side limit and also determine whether the limit exists or not. And last, we need to sketch a graph. So start from the example A. When the x approaches 0 or from left or from right, we know that x squared algebraically is always positive. So from here we can get that the limit will be 0 plus for the denominator, no matter it's from the left side or right side limit. So the overall ratio 1 over 0 plus, we get that both with the positive infinity. We can conclude that the limit exists but undefined with the positive infinity. So the graph it will be looks like when getting closer to 0 from left, going up, from right also going up. Example B. The denominator is a linear function x minus 1. It can be positive, it can be negative. So approaches 1 from left is the interval less than 1. Therefore, x minus 1 less than 0 denote 0 minus. After we substitute the 0 minus, the overall ratio is a negative. when we approaches 1 from the right, means that x is greater than 1, the interval will be greater than 0, which is the denominator is a 0 plus with the ratio positive infinity. How's the graph looks like? So we put that 1 as a boundary. Getting closer 1 from the left is a negative infinity. From the right is a positive infinity. We can conclude that the limit does not exist. Let's get some example of the assessment. Give it a try, you can make it.